Okay, so we're going to move on from segments and we're going to talk about rays and angles. So we're into section 1.4, rays and angles. Okay, the first thing we're going to talk about is something called opposite rays. So opposite rays. And those are collinear rays that share an endpoint. Okay, the word opposite implies that they go in opposite directions. So the way that this looks, if we think about a line and we have a point in the middle, let's say this is point J. Well, if we just look at J and we go to the right, we have a ray called JK. So let's pretend, don't do this in your picture, but pretend none of this is here. Right? So we just go from J and we go that way. So this is ray JK. Now, if we went from J the other direction, we might have a point out here called H. So from J through H is another ray. So JK and JH are opposite rays. Okay, opposite rays share a common endpoint. One goes one way, one goes the opposite way. So those are called opposite rays. They make a line. This is called a common endpoint. Just something for you to get familiar to saying common means they both have it. All right? So that's the first thing, opposite rays. Pretty basic. All right, now we're going to move on and talk about angles. Now, opposite rays are kind of an angle. They form a type of angle, but we're going to talk specifically about different angles that you probably already know about. But first, we need to learn how to label them and how to talk about them. So let's draw an angle. And an angle looks like this, right? And we're going to put A, B, C. Okay, angles are two rays with a common endpoint. Okay, so notice that's different than opposite rays, right? Opposite rays were collinear rays, so it means they were on a line together. An angle is just two rays that have a common endpoint. So B is the common endpoint. So if we look at our angle here, we see that we have ray BA and we have ray BC. Those are called the sides. So they are the sides. So that's a word we need to know. We need to know sides. And B, point B, is the vertex. You probably already know these words. So angle, here it is, BA and BC are the sides, and B is the vertex. Right? There's three ways to name an angle. So let's take a look at our angle we've drawn here. So three ways to name. So the first way is we can say that this is angle A, B, C. Or we could say it's angle CBA. Doesn't matter, but we go around the angle. So we start at one point on one of the rays, A. We go to the vertex, B, and then we go to the other ray, C. The only thing that has to be in the right place is the B. This is the vertex. Must be in the middle. Okay, that's the only thing. The vertex has to be in the middle. We can also just call this angle B. Okay, so we look over here at this angle, it's angle B. Now, we can only do this, and it's important that you make note of this. only if no other angle has the same vertex. Okay, so what I mean by that is, you see an angle like this, that's okay. But if you see an angle like this, and we have a B here, right? This is not okay, because I don't know if we're talking about the top angle, I don't know if we're talking about the bottom angle, or I don't know if we're talking about the entire big angle. So that we can't call angle B. And you'll see that soon. We'll practice it a lot more. There's one other way that you can name an angle. We could call this, if it was marked this way, if it had a 1 or a number inside the angle right here. Now, not like 45 degrees or something. If it just has a little number, like a 1 or a 2 or a 3 right there, then we can also say that this is angle 1. All right, and again, write down, this does not mean 1 degree. It means that's angle number 1, and we're going to have several angles. That's going to be number 1. 3 ways to name an angle. Now, there are 4 types of angles, and we're going to classify those 4 types. So if you see something that says anything about classifying angles, okay, classifying angles, it means to say whether they are right, acute, obtuse, or straight. All right, and we're going to make some little notes about each of these. I know you already know what these mean, but we're going to make some little notes anyway. So, a right angle, it looks like this. It will have a right angle symbol in the corner, or it will tell you that it's 90 degrees. A, B, C. And what we would say here is that the measure of angle A, B, C equals 90 degrees. So it's very important. This means the measure. Okay, if you don't write that, I don't know that you're talking about numbers. I might think you're talking about the angle just as an angle. When you put the M, that lets everybody know that we're working with the number, the 90 degrees, not the angle ABC. All right, an acute angle. Acute angle looks like this. You know what it looks like. It's less than 90 degrees. And we're going to call this one angle 1. So we get used to writing the numbers also. And what we would say here is that angle 1 is greater than 0, but less than 90 degrees. And you want to be careful. See how my little angle symbol isn't perfect? You don't want to mix up your angle symbols and your less than and greater than symbols. That can get really confusing when you start writing really long stuff out. Okay, an obtuse angle. You know what it looks like. It's a big, fat, wide angle. So we'll have J, K, L. And you know that it's between 90 degrees and 180 degrees. And so notice, see how my little angle symbol and my L and my greater thans and less thans, mine are pretty iffy, and I'm teaching you how to do it. So be careful when you're drawing them. Make sure that you do a really good job, because when I'm grading your papers, I've got to know that you meant greater than and not, you don't think that's another L. All right, our last one is called a straight angle, and you've seen it before. It's just a line. So let's say we have X, Y, Z. But this is also opposite rays, isn't it? And what we'll say here is that the measure of angle XYZ is equal to 180 degrees. Right, so those are the types of angles we're going to work with, and that's how you classify them. Classify means right, acute, obtuse, or straight. So we're going to keep writing here. This is going to be a little longer than most of them, but you'll be okay. So we're going to draw an angle. And we're going to put another little ray right in the middle. So try to split this angle into two other angles. Then we're going to go around and label it. So we have A, B, C will be the big outside angle, and the inside ray will be ray B, D. And we're going to learn about something called an angle bisector. So we need to write this down. An angle bisector, vocabulary word, is a ray that divides an angle into two congruent angles. So an angle into two congruent angles. Okay, we need to know what an angle bisector is. Now, I just said those angles are congruent, right? So in our picture here, ray BD is an angle bisector of angle ABC. Now, in our picture, we don't have anything that indicates that to us yet, so we're going to add something in here. We're going to put a little curve here and another little curve staggered from it right here. Okay, these are called, just like our tick marks on our segments, these are called arc marks, and they indicate that two angles are congruent to each other. Okay, so congruent angles are marked with arc marks. Now I want to do a quick example right off the bat of how angle bisectors are going to be worked with in geometry. So we need to write down our example. So ray KM bisects angle JKL. And then we're going to see that the measure of angle JKM equals 4x plus 6 degrees, and the measure of angle MKL equals 7x minus 12 degrees. And your instructions would be find the measure of angle JKL. So when you look at this, this is all you get. You get a bunch of words, some symbols, and a couple of algebra expressions. You have to take that information and turn it into a geometry problem that you can actually solve. So the way to do this is to just start with a picture. So the first thing we read here that says ray KM bisects angle JKL. That tells us what the picture looks like. It tells us that there is an angle JKL, and it is bisected by a ray KM. Now, bisect means that it splits it into two equal parts. So we put one mark here and one mark here. Our arc marks indicate that we know those two angles are the same. So we just read along. Measure of angle JKM is 4x plus 6 degrees. That's this angle. The measure of angle MKL is 7x minus 12 degrees. So those are the measurements of our two angles. All right, now how do we figure out find measure of angle JKL? Well, that is this entire angle. That's what we're trying to figure out. So the only bit of information we know is that these two angles are congruent. So we start with that. 4x plus 6 is equal to 7x minus 12. And from there we get into something very familiar, which is our algebra that we're all very comfortable with. So 6 equals 3x minus 12. We solve this out and we come up with x is equal to 6. And we're happy because we found x, but we got to be careful because the problem didn't say to find x. It said find the measure of angle JKL. So we have a little more work to do. So the measure of angle JKL. Well, that's the entire angle, right? But we know those two smaller angles are the same. So if we can take 4x plus 6 and substitute our x back in, we get 24 plus 6, 30 degrees, right? Then we can take our other angle, 7x minus 12, and substitute our 6, and we also get 30 degrees. Now, that's supposed to happen because those two angles are equal. So the measure of angle JKL equals 60 degrees. So hopefully that makes sense. If not, you can definitely ask about it tomorrow. We'll talk about it and it'll make some sense. There's only one more thing we have to write down, and I just want you to write it. So we talked about something called a segment addition postulate. So now we have something called an angle addition postulate. Angle addition postulate. So let's take a look at an angle. So let's say we have angle ABC. It's always a good one. Now we're going to split this angle, but we're not going to split it exactly in half, even though it could be split exactly in half. We're going to split it where it's obviously one bigger than the other one, just for the purposes of our picture. So we're going to call that D. So ray BD is between or on the interior of angle ABC. Okay, so you may hear that word, interior. That just means it's inside the angle. Exterior would be outside the angle. So our angle addition postulate says if D is in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Now, just write it down, because I know when you read that it may not make a lot of sense, but what it's saying is the same thing as our segment addition postulate, that this part plus this part equals this whole. Okay, so it's the same idea. We have two parts, they make up the whole. So we add the two parts together and we get the whole. So put a box around this. This is an important one. Angle addition postulate. You're going to see that on tests, on quizzes. You want to know it, be able to write it down. All right, so that's it. Have a great night.